Hey pre-calc, we are going to finish up with section 7.6, and yeah, we're just going to be doing exponential functions based off of this clue and these tables to be able to answer these questions. And what we'll be, I guess, doing in this first problem is trying to figure out what your A, B, and your C values are, and please notice that we have it implied in the directions that we have this exponent of negative x plus 2. So what I would start with is looking at the end behavior. Now, if you really wanted to, what you could do, I'm not saying you have to, but what you could do is just kind of give yourself an idea of where these values are, like negative 6, negative 1, negative 4 barely bigger than negative 1, negative 1 again barely bigger than negative 1, 2, negative 2, so like over here. And there's a few things I'm trying to get you to recognize. 5 is a very negative number and even more negative, and I think it's safe to assume at that point that we have a few things. One thing that you might mention is its decay. You might even mention we are below because it's going infinitely down, the horizontal asymptote. But the main thing that I want you to get at is, what do you think the horizontal asymptote would be? And why do I care about the horizontal asymptote? Well, I care about the horizontal asymptote because whatever this is, y equals, it's going to be the C value from the directions. And the other piece that we know is we already can tell based off of this that the A value must be a negative number in order to be below the horizontal asymptote. It has an x-axis reflection. So as we examine the end behavior, I'm going to say it's safe to assume that this is going infinitely down. So you might even write that as a statement. As x goes to negative infinity, what's h doing? And as x goes to positive infinity, I think it's safe to say that h is going to negative infinity. So as we look at to the left, though, it looks like to me that we're getting values that are closer and closer to negative 1. So that's what I'm going to conclude. I'm going to conclude that my C value in this problem must be negative 1. So that's the first piece to identify. The next piece, I'm going to strategically make my exponent 0. And you've heard me say this statement before, that the exponent, setting the argument equal to 0. And the reason why I want to do that is I want to see that when x is 2, the exponent will be 0. And why do I care about that? Is b to the 0 power will equal 1. So what I really care about is this ordered pair next. So let me write that out. So we have h of x is equal to a times b to the negative x plus 2 power. We now know that c equals negative 1. Well, if I strategically pick this value out, which is why I'm doing it, and x is 2, then we get a y value of negative 2. So negative 2 plus 2 is 0, b to the 0 power is 1, and what I have is this equation now, that a times 1 is still a, minus 1 is equal to negative 2. Well, I can add 1 over, and now I know that a equals negative 1. And that confirms my statement earlier that a must be a negative number because we're below the horizontal asymptote. The only other thing now is to figure out what the base should be. Now, it's up to you what value you want to use for the base. But to me, I would choose this. I don't know. There's not really a good value to choose. So what I would do, I don't know. This isn't even a great choice because I was trying to think of getting the base, the exponent to be 1. And that would only work if I had if I had positive 1 for my x value, because then negative 1 plus 2 would be 1. So there's not really a good value, but now I know that h of x, the a value we just found out is negative 1. We don't know the b value, negative x plus 2. We know the y value is 1. The C value is -1. So now what I'm going to do is just randomly pick a number, and I committed to -1, -1.064. So let me do that. What I'm doing is I'm replacing -1 in for x, so that makes it +1 plus 2 minus 1 needs to equal 1.064. Oops, -1.064. There we go. So now what I can do is I can add 1 over. Well, that's kind of nice. Adding 1 is just going to negate that -1. So we're looking at negative 0.064. And then we have this -1b to the third power. Well, we can get rid of the negative by dividing by -1. So it's going to become positive. And then what I would do is take it to the 1/3 power, just because I like exponents. But you'd be fine if you did the cube root. So that's what I'm going to do. I'm going to find my calculator, take 0.064 to the 1/3 power. Make sure you figure out how to use your calculator. So your base must be 0.4. Or 2/5 if you prefer fractions. I know I harp about fractions all day long. So you can change it to a fraction and make it 2/5. So how about I'll leave it as a decimal. So the best answer for h of x would be -1 times 0.4 to the -x plus 2 power minus 1. That's what we want. So feel free to hit pause, write down any questions you may have. Sorry, my 2's kind of look wonky. But bring questions to class. It is totally fine. So as we're looking at a few more problems, now we have f is defined like this. And we're just trying to figure out what a, b, and c are. So the quick answer is the c value is the horizontal asymptote, which we can tell just by looking at the graph is y equals 3. Now I would strategically figure out the where the exponent is equal to 0. So kind of, I guess I should have wrote down this. The c value is 3 then. So if I set the exponent equal to 0, then I want to figure out when x equals -2, what's the y coordinate? I think it's pretty clear from that the y coordinate is 2. So right now all we know is a times b to the x plus 2. We know the c value is 3. And what I'm going to do is I'm going to plug in -2 for this x. -2. And when I plug in -2 for that x, I have a y value of 2. And the reason why I chose -2 is -2 plus 2 is 0, and b to the 0 power is equal to 1. So now a plus 3 equals 2. Well, if I subtract 3 over, a will equal -1. So I'm starting to circle things that I care about. And that should be confirmed because if you look at the graph, we are below the horizontal asymptote. If we're below the horizontal asymptote, we should have a -a value. And now it's up to you to pick another point that looks like it goes through a particular point on the grid. Now, I would strategically choose this point. Looks like it's -6, -2. But you might find a different point. Like maybe you think this is -4, 1, and you might have a slightly different answer. So make sure you clearly identify. So I'm going to underline this several times. And again, what I'm looking at is where they cross the x-axis. Where they cross the grid. I was thinking that sometimes the directions will tell you what the x-intercept is, but this one does not. Sometimes they tell you the y-intercept, this one does not. So what I'm going to do is take that same equation we just wrote out. I'll switch colors again. Now we know -1 is replacing the a. b to the x plus 2 power, well, I'm going to replace x with -6 plus 2 power. We know the y value is 3, and it looks like from the graph that the y value will be -2 from this. If you're confused where I'm getting any of these numbers, we know a, we found that out. We know c, we found that out. And now I strategically put -6 in for x and set the equation equal to -2. So from here, I would do some simplification. Negative 6 plus 2 is negative 4. And then over here, I would subtract 3 over and divide by negative 1. So negative 2 minus 3 is negative 5. Divided by negative 1 to make it positive 5. And then I can solve this by doing the negative 1/4 power. And I don't think this is a nice answer, so you definitely want to use a calculator. 5 to the negative 1/4 power. And make sure you know how to use your calculator. Like my calculator, I can do this. Some other calculators you need parentheses. Some calculators you can use the fraction key. But anyway, round to 3 decimals, 0.669 is your base. So your base is about 0.669. And I forgot to mention on the previous problem, but your base should make sense. If we go back to the problem, we had 1 reflection and we have a growth, so the base should be smaller than 1. And so let's go ahead and write the final answer. Let's see. I think they called it F. Capital F? Yeah. Is equal to negative 1 times the base we just found. Feel free to round to the positive x plus 2 power plus 3. So on this last problem, well, at least on this page, they want you to practice graphing, and just a few things to remember with your graph is you can always make a table of values, but let's just figure out what some of the function would look like. And what I'm talking about is if we just did 3/2 to the x power, I hope you recognize that that's an exponential growth, so it's going up and to the right, something like that, and it has a y-intercept of 0, 1. So what I'm going to conclude from this is that we can figure out what the graph will look like just on that knowledge alone. And the first thing that you might recognize is that we have to shift that graph down 2. So instead of being at the instead of having a horizontal asymptote at y equals 0, we can shift that down 2 units. So we're looking at y equals negative 2 as a horizontal asymptote. Now you should also notice that we have 2 reflections, reflecting over the x-axis and reflecting over the y-axis. So what does that mean for me is instead of being a growth, well, it's still actually going to be a growth because it has 2 reflections. So if you think about, well, if we were to reflect over the x-axis, it would be down here, but reflecting over the y-axis makes it go this way as well. And then one more thing is that when we have a reflection over both, so reflection over the y-axis and a -3, it will be shifted left 3. So instead of having an intercept right here, I need to count to the left 3 units as well. And yeah, I mean, this would be a very, very lame graph if this is all I did. Okay, but I do want to point out that we could make this answer just a little bit better just by putting in one more point. And that's by, if I were to plug in 1 in for x, 3/2 to the 1/2 power would be 3/2. Sorry, it kind of went off my grid. There we go. So if I made that XY chart like I've been asking you to do, and you went through all of the transformations, negative x minus 3, and then negative y minus 2, and you just did those 2 points, I think you would find enough of an ordered pair to get the right answer. And instead of rushing through this, I think I'll stop right here and we'll finish up this graph in my second video. So I'm going to leave it right here and come right back to it.